Hello, everybody. We're going to do a double act today, G and I. So we're going to talk about iOS SDK, or SDKs, as it will become clear during the session. So just a quick word about ourselves. So G over here is working for CA Consulting, and I'm working for Alfresco. And both of us have been involved in the development of the libraries that we're going to present today. So before we start, why two of us? Well, there are actually, as I said, two libraries. So one is the library that is called ObjectiveC Mis, which is the CMIS-based library that we're going to submit to Apache, and G will cover that aspect. I will cover the other part of the library, which is the one that is called the Alfresco SDK, which is the library also being made public, and going to explain a little bit about that. But before I start, a quick show of hands. We did that same thing in Berlin. I mean, how many people here in the audience have developed Objective-C applications before? Okay. How many plan to do so in the next 12 months? Okay. How many are thinking are sitting on the fence? There's the rest probably. Okay, before we start, let me just say a few words about what this is not, right? This is not a talk about how to write applications in iOS, because that's a huge subject, and there's plenty of material out there. Not least by Apple, that provide a wealth of information in terms of tutorials, and of course there are books aplenty. And but I mean, Apple obviously would be my first choice and my first stop there. So this isn't about that. This is really about the SDK, and why an SDK in the first place. Well, mobile applications are very popular, as we all know. I think Apple has well in excess. Well, I think they probably hit now 1 million applications, or not very far away. Android not very far behind, or or probably the same level. And a number of applications, of course, are games and end consumer applications. But increasingly, a number of these applications also address the business community and enterprise. And so why an SDK again? There are two reasons really. Well, first of all, if you're starting with iOS, or if you just recently started with iOS or thinking about iOS, there is really two big hurdles to climb. First of all, to get familiar with the language itself, which is a little bit different to the common languages like Java and C++. And then, of course, there's the other hurdle to climb, which is to get to grips with, connecting with Alfresco server, how to operate a CMIS, and all the rest of it. So we thought we'd give you a handle on how to take at least that part of the equation out, and sort of give you a library that gives you a chance to just focus on application development, rather than to worry about how do I connect with an Alfresco server, and how do I deal with the whole, how do I implement the CMIS standard. Right, so that's just as a prelim. So now I hand over to G, who will talk about ObjectiveC Mis. This talk will be a little bit technical, but don't be afraid. So we'll take it slowly, and if you, of course, have any questions, then please ask. Okay, G, over to you.
All right, like Peter mentioned, I'm going to be talking about ObjectiveC Mis. And just right off the bat, what is ObjectiveC Mis? Since a lot of you guys are new, but basically what it is it's a low-level API for interacting with your CMIS repositories. It's a client API. It's implemented, or it's provided as a static Cocoa Touch library, and so that means it's for iOS only. If you want to use for your Mac apps, there's some steps you need to do, but as it stands, it's for iOS. It doesn't use any third-party APIs, libraries, frameworks, and this really was done so that we could contribute the project to Apache Chemistry. The library is also asynchronous, and we provide the asynchronous behavior using Objective-C blocks. So if you're familiar with iOS development. We don't use Grand Central Dispatch, nor do we use NS operations or operation queues. And then finally, the library only supports the Atom Pub binding, and it's the CMIS 1.0 spec of the Atom Pub binding, not the 1.1. In the future, we're probably going to be supporting browser bindings. I don't know when, but it's something that I'd like to do if I get some free time sooner rather than later. So that's just introducing the library just real quickly at a high level. ObjectiveC Mis comes as an Xcode project, and the Xcode project has 2 build targets. The 2 targets are, of course, your API, your CMIS API library, and the second is your documentation. In the documentation, what that target does is it provides Apple-like documentation. It generates Apple-like documentation and does the build and puts it into your Xcode development environment. And we do that using a tool called AppleDoc, and I'll talk a little bit about it later on. Now, to use the Xcode project, you will need Xcode 4.2 or 3, or 4.2 or 4.3, but I do recommend using the latest version, and I think that's Apple's recommendation, to always be at the latest version of Xcode. Your iOS version needs to be 5.1 or newer, and we peg it at 5.1 just because we want to use automatic reference counting in the library, and of course, like I said, ObjectiveC blocks. Now, before I really jump into more of the technical details, like I was mentioning, the project is open source. It's an open source ObjectiveC static Cocoa Touch library implementation for your CMIS API. It's licensed. It's under the Apache 2.0 open source license, so it's pretty liberal. It's a collaborative project, so there are several organizations that were actually contributing to this project. Thanks to Alfresco, they actually kicked it off, which was great. And then finally, like I mentioned, the project has been given or contributed to Apache Chemistry. They've accepted it, so it's in the process of getting added to the Apache Chemistry project, and pretty soon you'll see ObjectiveC Mis as a sub-project on the homepage. All right, so back to the technical details. So there's a couple of iOS-specific points. The first one is the naming convention. You're going to find that all classes in ObjectiveC Mis are prefixed with CMIS. If you're familiar with ObjectiveC, ObjectiveC has no namespaces. So this is how we provide namespacing. Error handling. In iOS, it's different where you don't ever throw exceptions. If you throw an exception, your app's going to crash. And so the proper way to do this in iOS is to pass around an error object. And so if you guys see an error object, that means you need to check for an error state. If you see an error, check to see if something failed. If it is a fail, then your NS error object is going to have your error information. The third is automatic reference counting. We use automatic reference counting so you don't have to explicitly manage your memory. Woohoo, right? But even though we use automatic reference counting in ObjectiveC Mis, your projects don't have to use it, just because you're not going to be copying. You're not going to be adding the classes directly to your project. And finally, blocks. We use blocks, like I mentioned, for the asynchronous behavior. It is. Can you hear me? It's used for the asynchronous behavior, and it provides us, or it's used for asynchronous handling, and also, it's used for for callback functionality. And I'll go into a little more detail here on that stuff. So. I mentioned blocks, and I keep mentioning blocks, and they're important. So what are blocks? Blocks are they're closures for ObjectiveC or C or C++. For iOS, they're introduced in iOS 4, and you're actually going to see a lot of these Cocoa Touch libraries are going to start. They're actually exposing blocks as a way to handle asynchronous behavior. Now, the power of blocks is you can encapsulate code within a block, and then you pass that code around as an argument. So you basically have ad hoc functionality as a variable. And so, like I mentioned, it's good for callbacks, and the callbacks are used for asynchronous handling of the requests. Now, I'm going pretty quickly here, but the asynchronous handling here, what you'll see is in the black box is a completion block, and so your code, your app, is going to have a completion block, and you're going to message the CMIS API for whatever you want to do, with CMIS, and you're going to always provide it with a completion block. The CMIS API is going to do, it's going to do its logic on a background thread. It's going to do it asynchronously. Once it completes, successful or not, it's going to execute your completion block. Now, the completion block is where it's going to return your the objects that you want returned, and also an error and an error object. And in the completion block, as a developer, as you're writing the code, you're always going to provide two pieces of the code. You're going to provide an error. You're going to provide error handling if there's error, and you're going to provide excuse me, you're going to provide the successful handling whenever the completion block is successful. So those were just real quick. I know it's brief, but those are sort of the key highlights of the iOS specific points. Now going into a little bit of the design and architecture, and again, I'm going to be brief here. But if you're familiar with the OpenCMIS client, the OpenCMIS Java client API, the architecture is very similar. And so what that means is you're going to have essentially two APIs that you can interact with. The first is a client object API, which is it's a high-level object-oriented API, and the second is a bindings API. For most of your development use cases, you're probably going to want to just stay with the high-level object-oriented API. It's object-oriented. It's natural if you're an object-oriented programmer. It's easier to use and implement, and this is the layer where we would implement caching mechanisms. And right now, the only caching that we do implement, I believe, is just link cache, or a link cache. Now, if you do need more control of what you're doing with your CMIS API, or with your CMIS interactions, you would then use your bindings API. Now, the bindings API, it's implemented so it follows the CMIS domain model, fairly closely. So if you read the spec and you understand what the domain model is doing in the spec, you should understand what the binding API is doing. Like I said, it provides more control, but the expense of providing that more control is it's a bit messier, clunkier to implement. You're going to have a lot more lines of code to write to be able to use the bindings API. So, like I said, your most use cases, you're probably going to want to stay with your object-oriented API. And so, if we look at the common interfaces of the high-level API, you're going to see that the entry point is going to be a CMIS session object, and from the CMIS session object, you're going to have access to query results. You're going to have access to CMIS objects, which are your documents and folders, and also your repository information. There's a couple other objects that I didn't put up here, such as policies, ACLs, relationships, just because they're not fully really implemented and supported yet. But if they were, they would also be here on this diagram. So that's really it for my design and architecture. I know it's very brief. Let's see, I'm going to continue on here. So how do you get started using ObjectiveC Mis? If you're like me, I like to get the source code, throw into my project, and just start looking at things, stepping through code. And so to do that, there's two ways you can do this. The first, the easy way is to add a compiled binary and its header files to your existing Xcode, to your existing project. So to do this, you just download source code, or I'll go through the steps in the next slide, but it's really simple. You generate the compiled binary, add it to your project. This other option, which I sort of recommend, and I would sort of recommend to you guys to use, is to actually add the ObjectiveC Mis Xcode project to an Xcode workspace. Now, if you do this, it essentially extends your development workflow, the scope of your development workflow. And what I mean is, you now have full access to the source code of ObjectiveC Mis. You're not just going to be looking at the header files to see what's happening. So the next couple slides is the steps on how to actually do that. I'm going to be really brief here. Feel free to talk to me here online whenever you want. But basically, the important point is the first step is you download the source code and you build the binary, or sorry, you build it, and you run the shell script, build universal lib. And when you run that, it's going to go through and it's going to compile this library into a binary. And then you're going to get an output folder that has the binary and its header file. Now you just take that output folder, drag it to your project, and in the clip, where it has the highlighted row, that's exactly what I did. I just dragged that project into my, or the folder into my project, and that's how you would add it as a compiled binary. Now, steps 3 and 4, I'm just going to skip over because I have another slide where I'm going to go in a little more detail. But basically, once you add it in, you need to make sure your target dependency is set up. So you link the library, and then the next step is to configure 2 properties in your target build settings. Now, if you wanted to add ObjectiveC Mis as an Xcode project to an existing Xcode workspace, the setup is a little bit different, but basically you create or open up an Xcode workspace, you add the ObjectiveC Mis Xcode project to your workspace, and you want to add it as a sibling. As a sibling to your project. So in the clip, you'll see they're siblings. There's a DevCon project and an ObjectiveC Mis project, and they're siblings. You can actually nest them, but you don't need to. So once that's completed, then steps 3 and 4 are the same, and I'm going to actually go over those in the next slide. But you configure your build target dependencies, you configure your target build settings, and then the 5th step, it's optional. I was thinking about it more. It's probably not optional. What you do want to do is you want to configure your project build scheme, and in Xcode, your project build scheme it maps out how projects are built. Now, the reason for doing this is so that when you get an error, or it doesn't get confused about which projects to build first. Xcode, it's supposed to be good at this, but it's still not there yet. Sometimes they'll get confused, and if it does, you just do a clean and then rebuild everything. All right, so in a nutshell, the first step is really adding ObjectiveC Mis to your project, be it the binary or the Xcode project to a workspace. The second is linking the library. So if you open up, when you're in Xcode, all you need to do is make sure that the library lib ObjectiveC Mis.a, it's going to look exactly like that, it has been linked to your target build. The third step is you're going to configure 2 properties in your target build settings. And the first setting is the user header search path. And this one, you configure this one so that your target build knows where to find its header files, or the header files for the library. And in the most generic case, if you just set that, then you're pretty set. Now, the second one is other linker flags, and these 2 flags are necessary. I believe the first one is necessary because we're using categories, and with Cocoa Touch libraries, it has issues with categories. There's an article. Should have linked it here, but basically, if you add that flag, and then the other flag is just telling it to load all the header files, and if you do that, you're golden. All right, so that's pretty much it for getting ObjectiveC Mis into your project. Now, with Apple, they provide excellent documentation, and they provide it as a documentation set. And if you actually get the documentation set, it's going to look very similar to this. And when you generate the documentation for ObjectiveC Mis, it'll look very similar to this. Now, the way that this is done is we use a tool again that is called AppleDoc. And if you go to generalbytes.com/AppleDoc, that's the author of that tool, or the owner. And it'll go into no more detail. But to set up AppleDoc and to generate the documentation, it's pretty simple. The first step is setting up AppleDoc. So download the source code from GitHub, and then just run the install AppleDoc script. And you'll find that script in the root of the source folder. If you use Mac ports, there's a port that you can use. I actually use Mac ports, and that's how I got it in. If you use Homebrew, you can actually use Homebrew to get it in. Now, once you have AppleDoc available, you need to generate the documentation, and this one's even simpler. You just open up the ObjectiveC Mis Xcode project, and you run the documentation project. And there's a run script, or there's a script that gets executed. And once the documentation target completes, your documentation is all set. If you go to the documentation tab on your organizer in Xcode, it'll be there. So that's it. That's all you need to do to get your build or your developer environment set for ObjectiveC Mis. Now, I do want to point out, if you do use the Alfresco iOS SDK, you can actually skip these steps. You'll get it with the Alfresco iOS SDK. All right, so now your environment is set up. A couple of code examples. I'm going to go over 3, and it's more so just to introduce how to use some of the calls, but more about the completion block. Now, here, like I mentioned, the CMIS session object is your entry point. And so to set up a CMIS session object, it's pretty straightforward. You just create a CMIS session parameters object and initialize it. Since we only have Atom pub binding type, that's the only type that is available. Provide the Atom pub service document location, username, password, repository ID. So that's your session parameters. Now, on CMIS session, there's a static class method called connect with session parameters. It takes 2 arguments, session parameters and a completion block. Now, when you message the connect with session parameters and you provide it the session parameters and the completion block, the API is going to go and try to connect that session. And when it completes its execution, it's going to execute the completion block. And like I mentioned earlier, the completion block needs to handle 2 states, your error and your success. So that's what we do. We check to see if we have a session object. If we do have a session object, or sorry, if we don't have a session object, we have an error. It didn't connect. And so handle your error. You could dig into your error object to find out what happened. However, if CMIS session is not nil, then it was successful. So you can store it, do whatever you want with that session object. So, all right, so next example is getting the root collection or the root folder of your repository. Again, very simple, same structure. And so here you'll see at the very first line, on a CMIS session, there's a instance method called retrieve root folder with completion block. The argument that you provide is a completion block. And the completion block here is, again, it's shown inline. And same structure. I've left out a lot of code that you would do, but once the retrieve root folder with completion block completes its execution, it's going to call this completion block. And when you get that completion block, you check, did I get a folder object back? If I didn't, we know we have an error because we were expecting a folder object. So we handle your error. Otherwise, if you do have a folder object, then you're successful and do what you want on that folder object. So again, a very simple example showing the block structure with the completion block. And finally, the third example is a query. And it's very simple, but here the reason I show this one is it's structured a little bit differently. So what this shows is we actually declare a block as a variable initially, and that variable name is query comp block, as you see, and it takes 2 arguments, a CMIS page result and an NSR object, same type of structure. Then we have the code for handling the completion, or the code that gets executed when it completes. Same structure. Check if the page, your returned object, the page result is nil. If it is, we have an error. Handle it. If it's not nil, then it was successful, and do what you want to do with that page result object. And then to actually execute the query here, the last third of the code, we define our CMIS query, and then we execute it. And again, to execute a query on the CMIS session object, there's an instance method called query. There's actually a couple of them, but for simplicity, I just use this one. That takes 3 parameters: a query string, a search all versions Boolean flag, and the completion block. And first 2 are obvious. The third, instead of my previous 2 examples where I have a completion block inline, I just provide the argument. And so if you do it this way, you can have completion blocks that you reuse if you wanted to, or if you want to keep the code cleaner. Otherwise, there's a whole bunch of indentation that happens. So those are my 3 code examples. Now, if you do want to get the code, currently it is hosted on GitHub under the Alfresco team account, and name of the project is ObjectiveC Mis, and the URL is there on slide. It is in the process of getting added to the Apache chemistry subversion, and so when that happens, the Apache subversion source repository will actually be your master repository of where you want to get your source code, and that's where we'll be updating it. I'm going to try to get them to expose a read-only Git repository, but that's future. So with that, that's ObjectiveC Mis, and I'm going to have Peter talk about the Alfresco SDK.
Okay, well, thank you very much, G. It's a lot to take in, isn't it? Sort of, if you're not familiar with Objective-C, there are a lot of stuff that's floating around, blocks and all the like. So we're going to repeat it in a way. It's not that scary. So if you're familiar with C or Java, then I think you get up to speed with it fairly quickly. Obviously, learning a new language is always a little bit of a daunting task initially, and you have to ramp up. But as I said initially, there is a lot of help out there. And iOS being, of course, along with Android, Android and iOS are the two major platforms today in mobile world. So I think it is worthwhile getting into. So let's talk a little bit about Alfresco iOS SDK, and I start with the basics. So first of all, what's actually included? There are three elements. The first element is a set of samples apps. So we give you a set of examples that you can work through. There are in fact two samples, one which allows you to create a simple connection to a repository, and another one a little bit more sophisticated, which if time permits I can show you in a quick demo later on, simply called, and not sophisticatedly called, samples apps. Then the library itself, which is a simple static library that you can include, and we're going to talk about that in a while. And then some documentation, and as G kindly pointed out, that's something that we use AppleDoc for, because it's actually quite nice. It's the format that Apple uses in its own documentation. You can import it into your Xcode project. You can also look at it as HTML pages. The prerequisites, what you need is Xcode. The latest version is preferred, so Xcode 4.3, I believe it is now. iOS 6, I think iOS 6.1 is coming out very soon. I think the beta versions have been sent around recently. But we support iOS version 5.1 upwards. I don't think that's a major restriction. I think most people by now will have migrated to iOS 6, at least the vast majority. And there are a number of reasons for it. One is the automated reference counting that was mentioned in the previous session from G, which is just basically improved error management, memory management. JSON handling, which is needed by our REST APIs, and storyboards, which is used by our sample apps, and that's got something to do with the way that you build UI in iOS. So, how do I get the SDK? Another interesting question. So you simply go to our website, developeralfresco.com mobile. There you will find the library as a zip file, which you download. You can also go and get the source code itself if you're such inclined. So if you want to look into the gory details of how the whole thing is built. It's a public GitHub repository. And there's also some online documentation tutorial also available online as a PDF. I should point out that the slide is, of course, available on the DevCon website, so no need to write that down. So you can download the slides later on, and you have the links available. So G already talked a little bit about how to include that into your project. So I'm going to cover, and not go into great details here, so we don't have the time for that. But it's it comes as a zip file, and all it really is they include the static library and the header files into your project, and that's about it, really. So it's a 2-3 steps process. So I mean, if you're interested in the source code, then I would advise to go through the steps that G just described. So let's go through a little bit about the design principles. Since we're talking about network calls, it makes sense to do that asynchronously. I think we should clarify a little bit about what we mean by that. Asynchronous behavior, for those who are not that familiar with the kind of coding language, is usually the technique that you make a call that immediately returns. So if you have asynchronous behavior, what you normally would expect is you make a call, a program call that is, and then the program waits and waits and waits until the call completes. And of course, if you have network operations, that can be a major blocker. So if you imagine you have a UI and you select something and you wait until the network actually responds, which, you know, depending on the speed and all the other factors can take some time, then that's not a very good experience. But asynchronous basically means that it's creating in the background. So there's no hold up. And we're making use of that, so it's pretty standard practice. The main principle is a session service model. There are 3 components, that is, session to connect to the repository or cloud, services for making actually the transactions to the server, and then the actual data which is handled by the model classes. And I have a pretty diagram. Oh, okay, well, the blocks again. To handle asynchronous behavior. Blocks is, there are many different ways to do that in iOS or in Objective-C in general. Depends on what your favorite is. So there is so-called protocols in Java or C++ world. There would be the equivalent of interfaces. There's also something called notification services, which is, can be used in program, and blocks is another way of doing that for callbacks. And there are some advantages for using blocks. If you're getting into Objective-C and think about designing a program or developing an iOS application, then I would recommend you get into that. It's certainly worthwhile doing. So let's look a little bit about this. Let's look a little bit at the structure. So these are the major blocks. So what you will see is the 3 main components and ingredients. So you have the session, the services, and the model components. You also have the CMIS library included. So we talked about a CMIS library and now the Alfresco SDK. So the Alfresco SDK actually includes the CMIS library. So there's no extra work that you need to do. The OpenCMIS library is being made available to Apache as an open source, as G explained, and Alfresco SDK is incorporating that. So the purpose of that being is that because in another session it was mentioned earlier today that you have the CMIS calls, but you also have the REST API and public API, which makes all the additional calls that Alfresco has that are not covered by a CMIS standard. And so rather than having to deal with 2 of those, we have that as one library. So, okay. So what does that actually look like? We have 2 ways of creating sessions. So there is the enterprise and community, or what we call the on-premise sessions, and then the cloud sessions. They both need authentication, and both of them have also CMIS sessions that G mentioned earlier. And here on the right side in blue, you see the model classes like folder, you know, an Alfresco folder, and repository info, which gives you some information about the version number and all the likes. Authentication is quite different between on-premise and cloud. And I don't know how many of you attended the session earlier today that Peter Monks and Gethin ran on public API that gave you a good overview. I'm going to touch on that fairly quickly. But the way that you connect to a cloud server is very different to what we currently do on-premise. The services section, we haven't implemented actually all of the services yet, but I believe that we covered a fairly good chunk. So I split this diagram into 2 columns, essentially on the left side, starting with activity stream down to the person service, are the ones that use the public API or REST API. Sort of basically these are the Alfresco specific ones, if you like. And then on the right side, you see document folder search and version services, which are using the CMIS library. Right, and here you see also in blue the model or the data classes that are behind that. So, Let's create a session, shall we? So let's create a session connecting to a community or enterprise server. And again, we're going to look a little bit at code. We're starting with including the appropriate header file, which is the repository session. And you will also notice that what G mentioned earlier, that in Objective-C we don't have package structures as we do in Java, so we need to be a little bit smarter about the way we do the namespacing. So CMIS classes are always preceded with a CMIS. Alfresco, then, not surprisingly, preceded with Alfresco, so we have an Alfresco repository session. We create a property, another oddity in Objective-C, if you like. So in Java, you would have to, for instance, or in C++ and C, you would have to create setter and getter methods to access class variables. In Objective-C, you have the way to create properties which automatically create the setter and getter methods for you. And then we create a block. Again, a block is not, we use blocks for callbacks, right? So here we connect with the URL, we connect with the username, the password, we have the optional parameters. Because it's optional, we can pass in nil. And the completion block basically just tells you that is the piece of code that you want to execute, right? So as G explained earlier, we also have different ways of error handling. So no exceptions in iOS because it will bomb your app. And that's not very nice. So what you would do in any code is you would check the validity of the returned object. In this case, it's the session object. If the session object is nil, then you know something went wrong, and you need to check what the error is. So it gives you a way to handle the error. Otherwise, we simply set the session to, we set the class parameter to the session. Blocks are everywhere. So they're used in most methods, not all of them, but in most methods of Alfresco SDK. And they're also, like in the CMIS library, used to encapsulate the asynchronous REST API and CMIS calls. So another example is to get the children in the root folder. So another class, so that's the document folder service, which is doing the brunt work. That's basically the big class that we have to handle all the CMIS calls, or the majority of them. So in this case, it is a simple method of creating a CMIS, a folder service object. This is the way that you do that in Objective-C. So in C++ or in Java, you would have the new operator. So in Objective-C, you have these square brackets that you see everywhere, but it's more or less doing the same thing. So you initialize the document folder service with the session, because the session object holds important information like the authentication. And then you simply call the folders, the retrieved children in folder method, again with a completion block, exactly the same way that we did with creating a session in the first place. So what about cloud? So cloud is a little bit different because if you looked at the previous slide in the repository session, we passed in the username and the password. So basically, that is handled by the app, and the app is then passing that on to the repository. In cloud, the app doesn't pass the username and the password on. In fact, what happens is, I think what is generally known as the OAuth dance, but it is using a very different process. And in Alfresco SDK, we have provided you with a bunch of helper classes to help you on the way that shield the complexity. But the first thing that you have to do is to go to the developer portal and apply for an API key and a secret key. So there's a pair of secret passwords, if you like, that are unique to each application that you want to create. They need to be provided in the app. And as I said, we provide then the helper classes to handle the authentication process. The first one of which is a view controller, which is iOS speak for a widget or a UI class. That basically all it does is it loads the login page on the cloud server. Right? So for those of you who attended this morning's session, there is a login page which is where you put in your username and password. So you don't do that in the app, you do that actually on the server. So it connects to the login page, and it does then initiates the whole OAuth dance, which is get the authentication token, take the authentication token to get the access and the refresh token, and which are the data that are then returned to you, the app, in form of the Alfresco OAuth data. So these are the two classes that you need to handle connection with cloud. So let's do that then in code. So again, like with the repository session, we have an Alfresco cloud session, but we also import the two classes I just mentioned. So the OAuth data, which contain the authentication details that you need in order to handle all subsequent requests to the server, and the login view controller. So, you know, just another way to create and handle blocks. So you can create blocks as parameters, and this is exactly what we're doing here. So this is where we define what we actually do once the session is authenticated. So, which means you successfully logged in, put your password in, and then you got the access token back. So this is what this piece of code does. The piece of code says that once the OAuth data are not nil, which means everything's hunky-dory and everything's okay, you can create the cloud session with these data, that is, with the access token, and later on you would need the refresh token. So you use this block, this piece of code, as a parameter, and you pass it into the login view controller, and the login view controller then handles the whole authentication process for you. And you can do that from within your app. For instance, if you have a navigation controller, you would, you know, like, for instance, push view controller. If you go to the samples app, there's an example of how this is done. So, some demo. It's always a little bit tricky to demonstrate an SDK, but let's just try. It's a little bit hard to see, isn't it? It's a little bit big. Let me just scale this down. That might be better. So it's not a stunning graphics design, but that's not its intention and purpose. The main purpose really is to show you, get you going, give you some concrete code examples. So the samples app here, I'm simply using the repository. Where you log in, and if the network connection is working, there you go. You can you get examples of all for instance, here we're getting the documents in a particular site. And it gives you code examples of how, for instance, you can upload a document and how you can add a comment. So there are a number of code examples which actually exercise most of the SDK as it is today. And we have the same available also, for instance, for connecting to the cloud. So if we shall be brave, then we do that. So this is, for instance, what you would see, right? So this is actually a web view. So this is not actually the app. So this is a web page that you get on the server. So hopefully the network connection is okay. Let's just try that. Hopefully we've got a couple of minutes. Yep. Okay. And so what happened in this brief moment while I was thinking about it. So you log in, and then there's all this handling of authentication token, access token, but you don't actually have to do anything and worry about it. So there's another sample application that I haven't shown to you yet, which is called Hello Repository, which is simply a way of connecting to the repository and getting the root folder access. So which might be a good starting point. So let me just finish off my presentation. Just a few more words. So what about support? Let's talk about the CMIS library we had earlier. So there's an Apache mailing list that you can subscribe to, which is always a good source. Then there's obviously the chemistry website itself with all the documentation with the standard that you would need. And you can raise tickets in Jira for the ObjectiveC Mis component. With Alfresco, it's always good, I'm sure you know there's the Alfresco forums that you can go to. There's a category called Alfresco Mobile that I would recommend you go to. If you have a support agreement, then of course you can contact support. And you can raise tickets in Jira. Again, we use Jira for bug fixes or feature requests or suggestions. So it would be good if you could use that. So, yeah, well, this is about it. A lot of new buzzwords if you're not familiar with Objective-C. I hope that hasn't frightened you. If you have any questions, and I don't know if you have enough time, then we can handle perhaps a couple of them now. Otherwise, there's an engineering hour session tomorrow where we'll be available. It would also be great if you could rate this session so we get some feedback from you. Or if you have any other comments, then please let us know. But one comment that I would like to see perhaps straight away is with regards to the samples application. So we have now 2 samples applications. One which is a pretty comprehensive one, and one which is a very simple one. So now there's been a bit of a debate in Alfresco wondering whether we should actually have a set of sample applications that build upon each other. So, starting from very simple to the more complex, or whether we should have only one. So my question to you really is, so just maybe a quick show of hands, would you prefer one comprehensive sample application? If yes, then you could raise your hands now, or if you would prefer a set of tutorials that would build upon each other. Right, okay. Interestingly, that was the sort of the similar result that we had in Berlin. So, okay, well, let's end it there. Are there any questions? Have I all stunned you into silence about Objective-C? I hope not. It's great fun, actually, to do mobile application. It's very rewarding. So I'm sure that whoever raised his hand earlier who did a mobile application iOS will testify. Anyway, thanks for your attention. Thank you.